Welcome to the sixth video on electrostatics for grade 11s. In the last video we investigated the force between two charged objects, and I asked you to predict what effect the distance between the two charged objects would have on the force between them. And I also asked you to predict what you think would happen if the size of the charge on either of the objects or on both was increased or decreased. If they changed, what would the effect be on that force? So we've got a number of experiments here. We've got 7 to be exact, and we're only going to be dealing with the first 3 in this video. And in the first 3 experiments, the charge on the two objects was kept constant. So that is my controlled variable. My independent variable, the thing that I'm changing, was the distance between the two objects. It was 1 meter, then went to 2 meters, then to 3 meters. And the thing that I was measuring, my dependent variable, was the force between these two objects. The electrostatic force was 22,5 newtons, 5,625 newtons, and 2,5 newtons. So the best way to, we've got the table here, but the best way to investigate what the type of relationship is to actually go and graph it. So let's go and graph that. I'm going to enter the data. Remember, my x axis is my distance, and I started off at 1, and that was at 22.5. At 2 meters, the distance there, the force was 5.625, and at 3 meters the force was 2.5. I'm not going to join the points. I want you to just have a look at what type of relationship exists. So let's have a look there. It does appear to me that it's an inverse relationship, because as my distance is increasing, the force is decreasing. So as my distance is increasing, my force is decreasing, and that would suggest an inverse relationship. Now in physical science in school, we're only going to be investigating 2 types of inverse relationships, either straightforward inverse relationship or inverse square relationship. To see which one is here, let's go to our trusty calculator and put in the values. So for experiment 1, I had 22.5 newtons of force. In experiment 2, I doubled the distance, but let's see how much smaller or how much greater experiment 1's force is to experiment 2's force. It was 5,625, and we see that it's 4 times smaller. So when I doubled it, it went 4 times smaller. That would suggest an inverse square relationship. Let's make sure by doing the 3rd experiment. So as I tripled my distance, I got 9 times smaller. So it definitely appears to be an inverse square relationship. Now I'm going to quickly enter in the equation. Don't you fret about the equation just yet. You'll learn about it as we carry on in the course. So it's 9 times 10 to the 9, and each of them had a charge of 5 times 10 to the minus 5. What is important, if it's inverse square, is that we're going to be doing x squared at the bottom, and let's have a look, and we see that it fits. So it is an inverse square.